Awesome. Complex numbers. So today's going to be a little complex. Oh no, don't look. Don't cheat. Don't cheat. Don't cheat. All right, so if I were to feed you this definition right here, what are some things that you could think to try? I'm saying don't look down. Don't look at what we're doing next. Just what are some things you might think to try? Well, hang on. I'm telling you, I is equal to that. I'm telling you that. I'm saying I equals that. What do you want to do? Anybody have any experimentation that you could try to do something to it just for fun? That seems kind of like possible, right? If you square I and you square the left side, you get I squared equals -1. Guess what's going to come back to bite us later in this class? That fact. No, we haven't done this yet. Oh. What about if you add a number? I don't know. Let's say, what's 1 plus... Can you combine those two things hard as you want to? There's no combining of like terms? Okay, so then could you combine these two things? No. Nope. So then could you combine these two things? No. But everybody wants to. It's not 5i. It's two different things. That's kind of where we're starting today. We've got a real part and we've got an imaginary part, and they don't get to combine. Cool? And that's where we're going. But now everything that flows out of this is pretty darn easy. I don't think it's going to be too tough. Before we get started, just a question. A quick poll. Why call it imaginary? Well, I think the I came from it being called imaginary, not... I think they picked I because of the word imaginary, not they picked the word imaginary because the variable they started using was I. Was there anything else you can't do? Right, negative number inside a square root is a domain restriction or a bad number. Why does that make it imaginary? Okay, better question. What's a real number? Can you think of an example of one real number? 5. That's real. These are all reals. 5 is real. You're right. Any other? 2. Sure thing. Any others? 0. Great. Any others? Get a little wonkier. -1. Cool. Get even crazy. Yep. -3/7. Is that real? Sure. What about pi? Yes. It's real, right? It exists in the world. I don't know where in a circle, if you divide it by the radius or whatever is the actual, I don't know the formula. But it exists. But you know what you can never even kind of measure or see or visualize or picture? That. I don't even know what that means. What that means is that somewhere along the way, somebody invented addition. And then you know what they had to invent right after addition? Subtraction, right? But then they were like, oh no, sometimes subtraction does too much work and we end up with a -7, right? Well, that's okay. We can visualize that. I can steal 7 cookies from you. Or I could steal 7. They're like, okay, we got a negative. We understand this negative thing because it's just stealing or taking away or I lost money. And then they invented multiplication because there's so many additions. If you add a bunch of times, right? It turns into multiplication. But once they invented multiplication, you know what they had to invent? Division. And now we got this weird thing that looks like that when you divide too much that it doesn't work evenly. But you know what's okay? 1/3. Because you know what they were allowed to picture back in the day whenever they invented math? They're like, oh, I could cut a cookie into 3 slices and keep 1. That's allowable. That's a real thing. I can really do that. But then when you multiply enough things, like your times a bunch of things, you know what you do? How do you simplify that? You square it. And as soon as they invented square, they had to invent square root. And then as soon as they did square roots, they encountered this negative number inside, and they're like, crap, We don't even know how to visualize that. We don't have a life example like cutting a pie in half or stealing cookies or taking a line and turning it into a cube. Well, I mean, I guess actually no. That's kind of the real math thing, is you take a dot and you turn it into a line, and then you take a line and you turn it into a square, and then you take a square and then you turn it into a cube. That's kind of what we just talked about, going from one dimension to two to three to just three. But then they get here and they're like, I can't do that. I can't take negative number and undo it. So we invented this imaginary system that said, this is not real. This is not real math. This is fake math, but we can still work it out and see what happens. So here we go. Now we get to the real, like, how does this play out? Just like this. You know what we do with that negative? There's a shortcut and a long way. I'm going to do the long way first, then I'll show you the shortcut. Here's the long way. Rewrite 24 as best as possible. What's the coolest way to rewrite negative 24? I think there's a cooler way, but you're right. 6 times 4? 3? Yeah, that's the coolest way, right? 4 square roots, that's the coolest way, but you're missing one thing. So I actually want to split it into 3 cool things. -1 times 6 times 4. And you know what properties of exponents tell us we can do with square roots? Because isn't a square root technically just a really ugly exponent? Right? Oh no, oh no, oh no. Well, we can separate them, right? And keep we can distribute the exponent across multiplication. Not across addition, but across multiplication. So we end up with -1, that's what we just learned, times root 6, we can't do that, times root 4. And what do we end up with? 2i root 6. You cool with that? Not too wild. On the website, there is a reducing radicals section under hard topics. So if you're just like, I can't reduce radicals, either A, come to office hours, we'll print out a worksheet and work through it, or B, check that hard topics section. Now there's this plotting thing. We don't do a whole lot, but it's worth showing you. Here we go. Quick review. Don't look down. Nobody look down. You can't look down. Also, I'll change the colors. This was blue and this was yellow, right? Don't look down. What was the blue thing called? Real what? I mean, it is a real number, but it's called the real part. And the yellow thing was called the imaginary part. Cool. And you know what? Just because they decided, remember, this is all made up anyways. This is all imaginary. They said, hey, what if we were to plot these like we plot normal things? The real part gets to be the x, which means the imaginary part gets to be the y. All right, so in order to plot -4, how far do we go over? -4, and how far do we go up or down? Down 1? That is -4 minus I plotted on the imaginary, what's it called? Plane. Cool. Did they give it a variable up above, or have they not even variabled it up, like A and B, A plus BI? Did they say that earlier? Oh, they did. Kind of a little bit right there. See how they said A plus BI? That's pretty common nomenclature or phrasing. So if you want to think of it as X is actually your A and Y is actually your B, that's totally allowable. But we don't see this graphing very much in pre-calculus. We see imaginary numbers a bunch because of what we're about to do in this next chapter, which is why we're starting with imaginary. Well, here, this is fun. What makes an imaginary number? What do you have to have in order to have an imaginary number? Per that definition right there, what do you have to have? You have to have a square root. Is there a super famous formula with a square root in it? That's why we're doing this. Because you can imagine what's coming next. It's quadratic and polynomial analysis. So, boo. But the good news is today's not too bad. It's Friday. You can subtract two numbers, right? And I'm here to tell you it works exactly like you think it should work. The way you would think a variable works is exactly how this works. So take away this red thing from this blue thing. So 3 minus 4i. There's one mistake that could happen here, which we've already seen a bunch in this class. Be really careful not to make it. Common mistake? Sure thing. Forgetting to distribute that negative across the second binomial. 3 minus 4i minus 2 minus 5i. Then there's the whole idea of combining like terms, and you end up with 1 minus 9i. I'll pause there. Any questions, comments, concerns, complaints? Yes. Even if they don't do it, which on the homework you'll see they do that a couple times just to be mean. Even if they give you the imaginary part first, just go, we don't want that, fix it, and then move on with the problem. I don't know why. It doesn't change the number, but it's just kind of what everyone does. And then I wrote this because today's going to be such a short day, so let's go ahead and add them just to see what happens. Anybody can do that without even writing any words? 5 plus 1i, which is really just 5 plus I. Not even have to do any work. Because it said from. The word from's doing a lot of work there. It didn't say subtract this minus that. It said subtract this from that. I know that's annoying. Because if you're reading fast on a test, you might miss it. And actually, first hour, I missed it. And I wrote it the wrong way, and then I had to erase it and fix it. But the word from is why. Subtract 2 from 5. You're left with 3, I would think. Alrighty. And with multiplication, I'm here to tell you, it's exactly like you would think. So without even reading the definition of multiplication, any ideas what we might do? Zoop, zoop. What's 5 times 1/2? What's 1/2 times negative 2i? Negative 2 over 2i? So 5 over 2 minus I? Pause. Questions, comments, concerns, complaints, conundrums, conniptions? Quandaries? Quandaries, questions, quandaries. Ah, what a quandary.
Nobody says that.
A ton of people say that. Quandary, yeah. Like, what a enigma. What?
Quandary, I've never heard that word.
Google it. You're on your computer anyways. Tell me the definition.
A state of perplexity or uncertainty over what to do in a difficult situation.
I like the British accent. I like the British accent that accompanied it. Did it say in British? Quandary, in British. State of perplexity. Oh, shoot. That's a quandary. We're going to go slow since we have time today, and there's probably somebody in the back or the middle or the front that's like, hey, you always just say you know how to FOIL, you're really good at FOIL, and then you don't do it. So here we go. This is for that person. I don't know who you are, but I will when I finish grading these tests. Those two things are first. Well, I should go this way. Are first in their each binomial. Those are the first, right? 4 comes first in this binomial. 2 comes first in this binomial, so we call that first. 4 times 2 is?
8.
Okay. Put a plus sign in the middle. I don't care what's coming next. I'm just putting a plus sign. I know you can do it faster and not do the plus if you don't need it, but all right, next one. Now we look at it like a sandwich. We're looking at the outside of the sandwich, or the bread, the 2 farthest outside things. And that's going to be negative 20i, right? Now we keep looking at it like a sandwich, and we're going inside. This is where we get that word foil from all the time. The inside of the sandwich gets multiplied. Oh, I forgot my plus sign. My non-colored plus sign. Because it's not being affected by the actual multiplication itself. Plus 6i. And then I'm out of colors. Green. Last but not least. Minus 15. Oh, I told you that was going to come back to bite us. Is there any like terms that can be combined? 8 plus. Those two look like they go together, right? Negative 14i. Right? Minus 15 times, and I told you this is coming back for us. I squared is actually just negative 1. So now we're looking at 8 plus. I'm going to go ahead and say minus. Because plus and negative is just subtraction. Plus 15. And now we're looking at 23 minus 14i. We did a FOIL. We did a pretty well organized FOIL, if I do say so myself. It's not bad handwriting. There are some people with worse handwriting that teach. You'll have them. They're great people. They're great teachers. Their handwriting, it's not as colorful as what I'll say. Questions on the FOIL? Questions on the today's math, which I would purport is just that step right there pretty much. That step is the today's math. That's all we've done really. Everything else is kind of left over. And I suppose the answer is today because you can't combine them and you got to know you can't combine. But all right. Let's move to the back page. All right, take a breather. We've just learned how to add. We've learned how to subtract. We've learned how to multiply, which you already know how to do. Dividing is the only slightly different thing. Dividing is the only thing that's like not dividing. Yeah, that's exactly the word. Conjugates. I might start by saying this for the homework's sake, because then we'll just save us some time for the homework. It says find the complex conjugate of this. Also, you're going to see it written like with the line over the top. Is that what you're about to say? Oh, because you've already looked at the homework today. Yeah. Okay. So that's just another way to write the question. I didn't do an answer. That's just another way to write this question. So find the complex conjugate of this. This is asking the same question. Find the complex conjugate of that. And if you look up above in bold, you could sum up the whole definition into one little definition. Anybody see those bold words up there? Change the sign of the imaginary part. It does not say change the sign in the middle. That's the temptation. And it happens a lot. It happens to me. It doesn't say change the sign in the middle. It says change the sign on the imaginary. Cool? So let's change the sign on the imaginary, and we're left with almost wrote 3. Boop, 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 boop. That's it. You just change the sign on the imaginary. That's how you do a conjugate. They are not This is not a tricky thing.
I'm confused by what you mean, change the sign of it.
Change the sign of the imaginary
No, when you say change the sign of it.
of the what?
You should not change the sign of it. That's what it does.
Don't change the sign in the middle, because what if they were trying to be sneaky and wrote it like this? Wait. Yeah, that's what I was trying to figure out. -3. The temptation here is to change the 3 real quick and just move on and write your multiplication or whatever. It's change the sign in front. Change the sign. That's why this bold definition is the perfect definition. Change the imaginary sign. Oh, you can even write it shorter. Change the imaginary sign. All right. Why do that? Why need to invent this whole new term that seems random and like pointless? For this exact reason. 2 plus 5i. Okay? We're dividing 2 plus 5i by 4 minus I. You know how to do that? No, okay, not without the conjugate. I'm saying, mathematically speaking, before today, which we haven't even learned, you know how to do that? No, nobody knows how to do that. And everybody, this is the temptation, and it's not good, it's bad. This is the temptation right there, right?
No.
Yes, it is. Don't lie. Maybe not for you, for somebody. Don't do that. Don't do this. Another temptation I see often. The thing that would be similar to would be if we were doing the same FOIL stuff we just did a second ago, just a random FOIL, right? And you were like, well, I only want to do that. You're not allowed to only do that, right? You have to do the FOIL or none of it. So similarly, you are not allowed to only cancel 2 lasts or only cancel 2 firsts. Eve, as tempting as it is. So, there we go. That's my spiel on please don't make these mistakes that I keep seeing. Here we go. So what's the point of learning this complex conjugate thing? For this right here. We're going to take the bottom and we're going to multiply by the complex conjugate. But are you just allowed to do that willy-nilly? Can you just throw out a multiply by a number? Nope. You know what you are allowed to do willy-nilly anytime you want? Multiply by 1. You're totally allowed to just multiply by 1. That is a legal thing to do. And then see what happens. To me, it looks like we're going to have to do 2 FOILs. That's what it's looking like here. So let's break into teams. Somebody do the first FOIL, left, team right. Somebody do the top FOIL, someone do the bottom FOIL. Tell me what you get. Go, go, go. I'm releasing you to do the FOIL. I don't know.
Pick one.
Yeah, just pick one. I'm trying to turn on music. It's not working. There it goes. All right, first person to get the top or the bottom gets $5. I don't have $5. Dude, I don't know. I haven't done it yet. No clue.
Oh, I agree with you.
For the top,
Yeah.
3 plus 22i. And if you're like, what the heck? How'd they get there? You know how they got there? FOIL. Well, if 2 people got it, it's probably pretty darn close. And you're right, I do trust you.
16 minus I squared.
Oh, but that I squared's got to do... Right, that I squared's got to change into something, right? What does the I squared change into? -1. Negative turns into a positive, and you're left with over 17? Oh, that means the people who did the top had to do another I squared thing as well, huh? You had an I squared thing happen in the middle there?
Yeah.
Okay. Good job then. Good way to recognize it and make it happen. That's not it. That's amazing.
No, I'm asking, but
I don't know. Is that the right answer? Let's see. 8 plus 20i minus 2i minus 5 negative 1 over 16. Cancel. Minus negative 1. So it'll be 17 on the bottom right. And, oh, did I mess up? Uh-oh. Did anybody not get this?
what? I don't know where you got the extra negative. They're both positive. The 5 is positive.
The 5 should turn into positive, so it's 13.
Wait. The 2 should be positive.
Plus the plus 2.
Oh, sure.
Yeah.
But what about the 5 at the end?
That's also the plus 5i squared.
And
So the 2 and the negative 5 cancel.
I'm glad I went back into this. Who said you let's do this foil. Let's do this top foil together. 4 times 2 is
8.
2 times I is
2i.
I almost did the same exact thing. 5i times 4. Okay, I'm cool with it so far, right? Those are going to end up turning into 22i, which we're awesome with. But then this is
Plus 5i squared.
oh, and then it turns negative. What?
I think it was these.
Oh, I'm so silly. I was looking up here. Being confused, not at the red. Okay. Yeah, great. Good job. I trusted you the whole time. Plus, you're saying it's going to be plus 5 I squared. I'm going to do it all. Yeah. And that I squared is actually going to turn into negative 1, which makes us subtract. I was looking at that 4 minus I and being, it went away so fast.
Clearly.
Somebody put it in my head too. Somebody's like, "You trust us?" So, then I doubted. I would say though the most common mistake that I've seen, especially when you get to the final, and this was so long ago, is forgetting to flip the sign and just going straight into it and doing 4 minus I over 4 multiplying by that. That's the most don't do that. But that's the most common mistake that I've seen, is forgetting to flip the signs and just still doing the good math, doing the good FOIL, doing everything right, except for I forgot to flip the signs at the beginning. Cool. Yeah, it's going to cancel. Or it's going to turn into 0, and you're going to get a nice, neat thing on the bottom. Kind of like that last one. We did one on the test that turned into 6. What's the long equation? The difference quotient? Remember the difference quotient? And how I was like, hey, stuff is going to start eliminating as you get to your final answer? Same thing here. It's going to start eliminating and crossing stuff out as you get to your final answer. If it doesn't, pause, go back, try a different conjugate. All right, this is just fun, and I like doing it because it's fun. So, what's I to the 1? We've already defined it today. None of these have correct answers. This is more having fun and exploring and building out a puzzle. What is I to the first power? What's another way to write it? Any other way to write I to the first power? Root of negative 1. What about I squared? You've picked the form. So before I do negative 1, which is true, look at this I. How can I write it in terms of i's? I times I. And now it's equal to negative 1. Totally cool. Now what about I cubed? What?
Are we gonna do it all?
No, because I'm actually not going to do I. I'm not going to do that either yet. I'm going to do I2 times I. And now I get to just pull the two answers from above. Because look, isn't I cubed just going to go in right here? And I is just going to go in right here? And we're left with negative root negative 1. Now, what about I to the 4th? How could we write that in a really cool way? That's exactly the cool way that I was thinking. Could you do it a different way and get the same answer? Absolutely. You could do I3 and I1 and make it happen. And what is I squared times I squared? Negative 1 times negative 1, which is 1. Now this is where it gets crazy. What about I5? I4 and I1. And what was I4? And what was I1? So isn't that the same thing as just I? What? What? And what about I6? What is it the same thing as? What? What about I7? What is it the same thing as? What about I8? Anybody know what I8 probably is? What about I12? Look at the pattern. What about I12? What about I10? What about I9? What about I11? What do you think is going to happen at, what's the next one? I'm bad at math. No, the next cool one. What about at I16? What about I20? What about I18? I don't know. Oh, how did you know? I don't know. We gotta. Maybe. Yes. Yeah. How else can you write it? That's really cool. I16 times I2. And what is I16? Like 4 times, right? I4 times I4 times I4 times I4, which is just what? What's I4? 1 times 1 times 1 times 1. I don't care how many times you do it. It's always going to, any multiple of 4 is just going to go bloop and turn into 1. And so I don't remember what I2 was. Oh, yes, I do, because it's the one important one. Negative 1?
Could you also do like the multiplication of it?
What do you mean?
Like I squared to the power of 4.
Or I4 squared?
Yeah.
That'd be funner. You could. Watch this. Either way, you just said it. You said, could we actually turn I16 into I4 squared? And that would just be 1 squared, which is just 1. Check mark. Or I squared to the 4th. This one's a little less obvious, but true. So what was I squared? Negative 1, right? So what is negative 1 to the 4th? Right, because it'd be negative 1 times negative 1 times negative 1 times negative 1. And each of those is just going to be 1 times 1. Yeah, you could work it that way. 100%. You can work it any way you want to. Heck, if you just want to write them all out because you can't remember and you want to get a good grade on the test, write them all out. You might run into a problem at 101, but all right, let's finish it up with this 101. Any ideas on what 2 numbers to break it up into? It's a good, close, divided by 4 or multiple of 4. I think there's a real close one. Really, really close. Think about quarters. And 100. 101 turn into 101, right? And what does 100 turn into? I to the 100th. Sure. So does 100 divide by 4 super nice and neat? So I to the 4th to the 25th. And you know what that turns into? 1 times I equals I. The cyclical power of I is it just turns into cycles of 4. Start at a number that's divisible by 4, and then you just go up 1, up 2, up 3, up 4, start over. Up 1, up 2, up 3, start over. Kind of